Assalamualaikum warahmatullahi wabarakatuh, and I wish everyone is well. My name is Abdul Muin bin Abdul Rahim. My matrix number DN2051. I'm with my partner, Mama Abid bin Rosdi. So I'll be explaining on the first half of the presentation, and he'll be explaining on the second half of this presentation. So our presentation is on the PBL2 about the 5G antenna design. So let's get on to it. Alright, so the contents of our slide are introduction, design of antenna, antenna characteristic, HFSS simulation, and result and discussion. So only 5 parts. So I'll be explaining on the introduction, design of antenna, and the antenna characteristics. Alright, so the introduction, the power of 5G connectivity. Why do we need 5G? So 5G, it is really known for its speed, reliability, and low latency. So low latency means like less or low disturbance. So the most common speed is the 20 gigabytes per second (Gbps). So it is very high speed. It can support high quality streaming, and it is like the future of connectivity. So microwave connection utilizing high frequency radio wave are vital for long distance wireless communication. Operating between 6 and 38 gigahertz. So this is like all the connection basically. So 5G, 3G, 4G, 5G, 3G, all of it is in the microwave area. So it supports telecommunication, anything like the defense industry, communication. So pretty much why we need to study on the microwave itself. All right, that's enough for the introduction. All right, the design of antenna. There are three common antenna design: dipole, parabolic, and patch antenna. So a dipole antenna, it is two symmetrical conductive element. Um, you would say that it is used in TV, or dipole is basically like it has two metals because it is dipole, so two. You commonly see in TV, amateur radio, and wireless network for its simplicity and cost effectiveness. You might see in old TVs antenna, so that is the dipole antenna. So parabolic dish antenna. A parabolic dish antenna featuring a concave reflector focuses radio waves onto a central feed element for high gain and directivity. So parabolic dish antenna, I would simply describe it as the astro antenna because it has the like concave shape with the central feed on itself. So lastly is the patch antenna. A patch antenna with a flat conductive patch of a substrate is designed for planar transmission of radio wave. So patch antenna, it is in a way that it is patched because it is a flat antenna. You put it flat on the surface, and the waves is directed up. So one of the most popular usage of a patch antenna is in the DC Mac flat face, which is the Tesla Starlink internet connection. So that is the patch antenna, and we chose patch antenna as our main design for our 5G satellite design for this assignment. Alright, so antenna characteristic. There will be five that we focuses on: gain, bandwidth, radiation pattern, polarization, and efficiency. So gain. What is gain? Gain is the measure of how effectively an antenna can transmit or receive signal in a particular direction. Bandwidth. It determines the range of frequencies an antenna can transmit or receive without significant loss in performance. So bandwidth in a way is the range of what it can transmit, because some bandwidth are different than others, so it doesn't overlap each other. Alright, radiation pattern. Radiation pattern of the microwave itself, it will be omnidirectional, bidirectional, or highly directional depending on the antenna design and application. So it means that radiation pattern is not one fits all. It is based on the antenna itself. Patch antenna will be different, dipole antenna will be different, and the parabolic will be different. So polarization. Polarization, it is the emission and receiving of the electromagnetic wave within a particular polarization orientation. And lastly is the efficiency. It is how an antenna converts input power into radiated energy. So I think that is all from me because I've already covered the first half. So I'll pass it on to my friend Muhammad Abi bin Rosdi for the other half. So that's all from me. Thank you.
Assalamualaikum and hi, my name is Mama Abi bin Rosdi and my matrix number is DN200103. So for my part is I will explain about this HFSS simulation. So the antenna that we choose is patch antenna. So the antenna design is we have the target frequency which is 2.4 gigahertz. For the dielectric constant is 4.4 millimeter, and for the dielectric height is 1.6 millimeter. Next, for the physical parameters of this patch antenna, for the length is 29.44 millimeter, and for the width is 38.03 millimeter. And the calculated input impedance at antenna H is 243 ohms. So as we can see, insight gain for impedance matching and overall antenna performance optimization in HFSS simulation. And for this design, patch antenna uh, will have the ground, substrate, and the patch. So next we have the feed and port to the patch antenna, and we also needed a radiation box. So after finishing the design, we need to run the simulation, and here it is the result of the simulation, which is, as we can see, that the radiation plot for the patch antenna and the electric field radiation on the antenna. And also for this radiation pattern for E field and radiation pattern for H field. And we can conclude that the max gain for this antenna is at 2.2 gigahertz and 2.1755 decibels. So for the last part is discussion on how we create this patch antenna. So the ANSYS HFSS analysis provides valuable insights into the electric field magnitude within a patch antenna substrate. So subsequent radiation pattern analysis at 1.42 GHz reveals a peak gain of 2.1755 decibels at 2.2 GHz, means that emphasizing the antenna's performance characteristic. So I think that's all from me. Thank you.